Do you know how to find maximum appearing element in a range? If your answer is no, then this video is for you. Hi guys, I Aziz welcome you to CoedMaster, and in this video I am going to talk about how to find maximum appearing element in a range. So let's get started. Alright guys, let's begin this video with this problem. The problem is given as we are given two arrays and these two arrays represents the starting and ending index of the range. Okay, for example, if we consider the first element of both the array, this means the range starts from 1 to 5. If we consider second element of both the array, this represents the range 2 to 8. And if we consider third element of the given array, this element represents range from 5 to 7, so on and so forth. And in this problem, our task is to find maximum appearing element in a range. Okay, so have a look. In range 1 to 5, we have elements 1, 2, 3, 4, 5. In range 2 to 8, we have elements 2, 4, 5, 6, 7, 8. In range 5 to 7, we have elements 5, 6, 7. In range of 10 to 12, we have elements 10, 11 and 12. And you can see among all the ranges, the maximum appearing element is number 5. Because it appears in range 1 also, it appears in range 2 also, and it appears in range 3 also. Okay, that is why the output of this input is 5. Okay, now here I would like to mention few constraints. So the number one constraint is the value of range, that is L of I and R of I, is always going to be between 0 to 100. This means our range is always going to be shorter. We are never going to get a range that is larger. This means the range value always exists between 0 to 100. Okay, and the second constraint is the index of the start and end array could go from 0 to 10 to the power 5. Right now there are 4 elements in the given array, but it could go up to 10 to the power 5. That is why it is written as index. Okay, so these are the two constraints of this problem. So I hope guys this problem is clear to you. So the first step to solve any problem is to understand the problem. And I hope that you understood this problem really well. Okay, moving forward. Now the question over here is how we are going to solve this problem. So here let me show you the brute force approach to solve this problem. So these are the given arrays and this array represents the starting and ending index of the range. Okay. And as per our observation, we already know that the range is always going to be between 0 to 100. So by considering this fact, we are going to create a frequency array of size 100. Okay, and initialize all the elements to 0. This is the first step we are doing in this approach. Second step is we are going to traverse the given array. This means we are going to traverse this given array start and end. And why is it so? To pick one range at a time. Okay, so we traverse like this: 1 and 5, then 2 and 8, then 5 to 7, and then 10 to 12. This way we get access to the ranges. Okay, once we get the access to ranges, then what we are going to do? We are going to traverse all the elements present in this range. For example, the first range is 1 to 5. So we traverse all the numbers from 1 to 5. Okay, so the next step we are going to do is, while traversing all the numbers of range, we are going to that particular index and increment the value by 1. For example, here the range is 1 to 5. So we are going from 1 to 5 and increment all the number by 1. Now next go to the second range. That range is 2 to 8. So we go to index 2 and increment all the numbers from 2 to 8. Now let's move on to next range. Next range is 5 to 7. So let's go to 5 first, increment it by 1, it becomes 3, then go to 6, then 7, and that's it. Okay, and the last range is 10 to 12. So we go to index 10, increment the value by 1, so it becomes 1, then 1, then 1. We do this from 10 to 12. So the frequency array of these ranges are going to be 0, 1, 2 2 2 1 0 1 1 1 1. Okay, great. So guys, if you look at this frequency array carefully, you will see that the maximum number of this frequency array is the output of this input. This means the index of the maximum number is going to be the maximum appearing element in the range. And here the index comes out to be index 5. And why is it like that? Because we are using indexes of the array as the elements of range. And the most appearing element of all the ranges is 5, because the appearance of this element in all the ranges is maximum. So this is the basic approach to solve this problem. So do you see guys what is happening over here? We are simply created the frequency array, initialize this array with 0, then we traverse all the ranges one by one, and while traversing all the ranges, we have traveled all the elements of that range and mark all the elements in the frequency array by incrementing the existing element of the frequency array by 1. And in the last, we found the maximum element, and the index of that maximum element is the maximum appearing element in the range. I hope this is clear to you. Now let's move on to the most important part of this approach, that is calculating the time and space complexity of this approach. Now what will be the time and space complexity of this approach? If you look at this approach carefully, you will see that first of all we are using one extra space to create this frequency array, right? And then we are traversing the array, means the given array, one time. So it's going to be n. And inside this array we are going to traverse all the elements of the range. It means this means we are running a loop for all the elements present in the range. So in worst condition we are going to run a loop maximum time, right? And here max could be 100, because as we know that the ranges is always going to be between 0 to 100. So in worst condition the maximum time this loop is going to run is 100. And you can see that these arrays are nested arrays. So we can say that the overall time complexity of this approach is going to be big of n into max, right? And space complexity, as we are using one extra array to store the frequencies, it comes out to be big of n. So guys, as you can see that finally this approach took big of n into max time complexity and big of n space complexity to solve this problem. But surprisingly, we have another way to solve this problem. And that approach is going to solve this problem in big of n plus maximum time complexity. So guys, now comes the interesting part of this video. And this is going to be the efficient approach to solve this problem. So let's see how we are going to solve this problem efficiently. So these are our given array, okay? Now in this approach, the first step is to create the frequency array. Similarly, we have done in the previous approach, okay? And initialized all the elements with 0. This is our first step. Now in second step, what we are going to do, instead of traversing all the elements of range, we just have to mark the beginning and the ending of range. Let me show you how. So this is our frequency array, and by default it is initialized with 0. We pick the first range 1 and 5. We go to index 1 and mark the beginning of this range as 1. Then we go to index 1 greater than 5, that is 6, and we mark it as the end of this range. But what does it mean? This means there is one range that starts from 1 and end till here. The next step is go to the next range, that is 2 and 8. Go to index 2 and mark its beginning, and then go to index 9, that is 1 greater than 8, and mark the ending of this range. Okay, now you can see that from this point till this point there are two ranges that starts from here and end here. Okay, now move on to next range. Next range is 5 and 7. So let's go to 5 to mark the beginning of this range, and go to number 8, that is the end of this range. Now you can see that there are three ranges that starts from this index and ends to this index, okay? And the last range is 10 and 12. So let's go to 10, mark it as starting of this range, and go to 13 to mark the end of this range. So now we are done, and now you can see that there are four ranges that begins with index 1 and ends at index 13. Now what's the next step after marking all the frequencies? So let me clear this thing that the remaining elements are marked as 0 by default, because while creating array all the elements are by default 0, okay? Now you will be stunned to know that we are going to use prefix sum to find the maximum appearing element. Yes, you heard that right. So let me show you how to find prefix sum. So prefix sum of first element is 0 because there are no elements to the left of it. Now prefix sum of this element is 0 plus 1, that is 0 plus 1, that is 1, okay? Then 1 plus 1 is 2. Now 2 plus 2 is 0. Again 2 plus 0 is 2. 2 plus 1 is 3. 3 minus 1 is 2. 2 plus 0 is 2. 2 minus 1 is 1. 1 minus 1 is 0. 1 plus 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 0 is 1. 1 minus 1 is 0. So this is how we compute prefix sum of all the frequency elements. Now here you can see that in all the prefix sum, the maximum prefix sum is 3 and the index of this element is 0, 1, 2, 3, 4, 5. So the step number 3 would be we have to traverse this prefix sum array and return the index of the maximum value, and that index is going to be the maximum element appear in the range. And how does it working? Because here also we are using the indexes of the frequency array as the beginning and the ending of the index of the range, right? So after computing the prefix sum, we come to know that this is the maximum number and the range and the index of this number is 5. So the final result of this computation is 5, that is the maximum appearing element in all the ranges. So guys, this is really cool thing, isn't it? That we used prefix sum array to find maximum appearing element in the range. And we have to say that this approach has done amazing job to find the maximum appearing element in the range. Now let's move on to the implementation of this efficient approach. So here you can see that we have a function maximum appearing elements, and this function is taking two array. So first array represents the starting index of all the ranges and the second array represents the ending index of all the ranges. Now next step is to create the frequency array. So here in next step we are creating a frequency array of size 101. And why 101? Because we are marking the end of the range to one element greater than the end index of the range, right? For example, the end index is 99, then we are marking the end of the range to 100. So that is why I took one number greater than 100. Okay? Now after creating frequency array, we are running a loop to mark beginning and the ending of the ranges. And then after marking all the ranges, we are going to calculate prefix sum of the frequency array. And along with finding the prefix sum of the array, we are also checking if frequency of j is greater than frequency of result or not. This means we are finding maximum number we have seen so far. And as soon as we find the maximum number, we simply store the index of that number into result variable. And eventually after for loop, we return the value of result variable. So this is all about this function. Now let's quickly see how it works. So here these are two arrays that represents the starting and the ending index of the range. First we are creating a frequency array and initialized all the elements with 0. Then we are traversing all the ranges and marking beginning and ending of the ranges, and we get the frequency array like this. After we have calculated all the frequency, in the last loop we are calculating the prefix sum of all the elements. We are also checking the maximum element we have seen so far. and we get the maximum as 3 and the index of this 3 is 5. So we return 5 in the last. So guys, this is really interesting way to solve this problem where we are using prefix sum. Now let's come to the interesting part of this approach, that is computing the time and space complexity. In previous approach, the time complexity came out to be big of n into max, if you remember. But in this approach, the time complexity came out to be big of n plus max. The reason is pretty simple. The first loop is running n times, correct? To mark the frequency of all the ranges. And n is equal to number of elements present in this array, given array, okay? And what is maximum? Let's say we had got range like 0 to 99. Then this array is going to run maximum 99 times, right? But if you observe this function, you will see that both the for loops are subsequent for loop. These are not nested for loop. That is why we are using n plus maximum. We are using plus symbol to represent the time complexity. Okay, great. Now what about space complexity? So in this approach also we are using the same frequency array to mark the frequency of all the ranges. That is why the space complexity remains the same, that is big of n. So guys, we have to say this, that this approach has done amazing job to solve this problem. So on this note, let's end this video. And guys, if you had learned anything valuable, and if you did, then please hit the like button and subscribe to this channel. And do not forget to click the bell icon so my friend you do not miss any future video. So this is all from my side. Thanks for watching and see you in the next video.